Hello, you're welcome to this class, and we are going to be looking at image processing MATLAB. This week, we want to go into the nitty-gritties of images and how to process them. So we're going to majorly center on image processing using MATLAB. I hope you have your MATLAB setup ready. Of course, you need to add some libraries or components in MATLAB, like the image processing toolbox and computer vision toolbox, and many others as will be going on. I'll be letting you know how to install them as we progress through the lecture this week. So it's going to be quite interesting, and it's going to be majorly short lecture, and then do a hands-on practical with the demonstrations. So you're welcome to this class. Our agenda is to look at an introduction and image processing, and look at what is image enhancement, image segmentation, image registration, and of course we shall wind up our topic in this regard. So when we're looking at major images or image processing, we are going to look at, there are much more image processing, and as I said earlier, many of you may have interest in this area, can be able to go a little deeper into research in image processing. We are going to have the basics and how we enhance an image, segment, and register that image. So you know that cameras are everywhere, and even your phone has one. So you might have a new idea for using your camera in an engineering or scientific application that you desire to do, maybe like a face recognition application or any other image processing application that you want to do, but have no idea where to start from. Image processing may be one of the areas that can interest you in doing that, using your gadget to do some stuff for you. So while image processing can seem like a black art, there are a few key workflows to learn that will get you started in using multimedia technologies. What are the applications of image and video processing? The medical imaging, for instance, if wanted to determine whether somebody has cancer or not, by taking an X-ray image, can we be able to process that image, make an analysis, and of course make a prediction that probably somebody has a disease or they don't have a disease, okay, or probably it is in early stages or advanced stages. So we can help the medics in easing their research and of course examinations and a number of other things. You can also use it in surveillance, looking at who attacked your house, or who was the criminal that you're looking at, and many other things. It is also applied in robotics and of course automotive safety, consumer electronics, geospatial computation, and machine vision, or what we call as computer vision, and of course many more other applications that it is applied. What are the common image processing challenges? One of the major challenges is reading and writing images into various file formats. It's quite a challenge. Uh, Images from one format to another. It may be a challenge for you to be able to write that. Also, creating and testing algorithms. What if scenarios? That's the word. What if, not with. It is what if scenarios. What if this? What if that? It may be a little challenging for you to test such kind of algorithms when you're dealing with image processing. It's quite a challenge. Identifying causes of algorithm failure is also a challenge. And of course, also visualizing images and intermediate results is a challenge. Processing large images with limited memory is also a challenge, because you may be having very large images and working on machines that are having limited memory. It may be a challenge for you to do image processing. But also executing algorithms faster because of running complex loops in algorithms may cause a little more time consuming and of course too much computation power, which is quite still a challenge that needs a little more research to optimize. But in this lecture, we would desire to explore the fundamentals of image processing and be particularly using MATLAB. There are many other languages that you can use to do image processing. You can use Python, you can use any other programming language, Java, many others. But MATLAB is a very good language that can help you do serious image processing without having too much hassles. So through several examples that we will cover and review, we'll have to look at a workflow for image enhancement, which involves removing noise and sharpening an image, making it a little more clearer if it has been blurred. And that will be our major essence in this lecture. And then segmentation of an image, where we're looking at isolating objects of interest and gathering statistics of that image. That's what we call image segmentation. That will be in our next slide or next video, or the face-to-face lecture. Then image registration, which involves aligning multiple images from different camera sources or from different satellite sources or from one source, and you have these images brought together, registration for comparison, number of other things, as we will see. So the goal of this lecture is to equip you with a set of common strategies to address typical image and video processing workflows. Okay, so okay, so we're saying that the goal of this lecture is for you to be equipped with a set of common strategies to address typical image and video processing workflows. You may have an image, like for instance, I have this image of toy candy. I have some toys on, and then the count is on. You may have such an image. We may look at wanting to have an image processed to this. Okay, so you have the canned image here, and you would want to process it to have a black and white, which is a binary image here. Please, there are slides that have and notes that have loaded on Moodle. Please endeavor to read on image and graphics. Okay, the type, the 2D, the 3D, and then the binary images, and how can we be able to work with images. Please endeavor to read that. Okay, we also want to look at performing an image processing analysis. Want to perform a visualization and look at how we come up with an algorithm. And in this, we're going to look at how to display image and explore. How do we enhance an image? If an image has been blurred, how can we be able to enhance it to have better results? We're going to look at image analysis, be able to analyze an image. We'll look at morphological operators, an image, then look at image registration and geometric transformation of an image, and ROI-based processing of an image. When we look at image processing workflow, you have access the image, and that's provided the hardware or the software and the files you have. You need to have your files together and collect them for you to be able to make them ready for processing. So the next step you go to is to explore and discover. And at this step, that's when you do data analysis, you do data modeling, you do algorithm development and application development. And so a lot of work is done at this stage here. Okay, so this can be a back and forth. Okay, as you do and you find it is not working well, you go back and check other inputs and then you continue. Then the third is to share. And sharing, you can be able to share with, or maybe on camera, sharing your application that you have developed or algorithm that you've developed, or reports that you have gotten from data analysis, the models that you have come up with, the applications that you have developed and you want to deploy them in MATLAB or in C++ or in Java or any other programming language. You can be able to come up that at that level, and then you have output for designs, and then be able to get to maybe to your friends, to get for the businesses that you're working for, and then you get back results, and then can be able to go through the process again. This is an iterative process. You go back and forth, until you come up with a very perfect application or a very perfect model or algorithm that you have come up with. Okay, so it's the much work is done at the stage 2 here of the processing workflow of the image. Okay, then what is an image enhancement? Because we want to look at that in this lecture. Here in the image enhancement, we look at the pre and post processing. So an image enhancement is the process of adjusting digital images so that the results are more suitable for display or for further processing. It is a process where you're adjusting a digital image to give you better results, make suitable displays for you to be able to make further processing some sort. So it involves you removing noise, doing deblurring, and sometimes filtering. Okay. So an example demo is we have this image, this is a satellite image that we're going to use, have this image here, and our goal is to enhance it to this image. This image is literally blurred, is literally vague, it has no color, it's a little more purple. How can we be able to enhance this image to become an image like this one? That's the goal for us to have to do this week. So our goal is to import and visualize an image. This is an image of map of Paris. So can be able to get an image. They will ask you to download one on internet, an image of Paris. You just put in map of Paris, and it is this color here. You download it. Okay. Then after downloading that, we're going to be able to import it and then do some visualization and see how things are happening with this image, and then understand how we can be able to enhance it to become a little better, to do some processing to this image. Two, we want to correct for poor contrast and unbalanced colors. You'll see that this has a poor contrast and has the colors are not balanced, and we want to come to something like this that has shades of green, we have blue, we have shades of red, a little more colors have been able to show up. So it's quite very important for us to understand our purpose as we looking at image processing. Okay, so we're going to launch into MATLAB, and at this moment I'll ask you to come with me to MATLAB. Launch your MATLAB on your computer. Mine is already launched. Okay, so I'm going to start. I already have a file that I've been working with. What we're going to do is, first of all, to get our image candy, and I told you that you can just go online. Okay, you go online and be able to get, let me say, type to Google, then you have map of Paris. This is purple. It's a purple picture. So I'll have images here. Perfect. It is this one here. You can see this image here. What I want. So you just get the image. You save the image as. I'll call it Purple Paris. Okay, Purple Paris. I'll be able to store that where I want it to be. Can be able to get that image stored in my folder here on the desktop. I have a folder here. Okay, so I think I need to save it as save image as. see this, save image as, okay, this brings it. I'll get this, I call it Paris. I save this image. I also want second image I want to play with is toy candy. So just come here. So toy candy is here. You can just get the image. It's here. Then download it. I already have it on my machine. Okay, so I'm going to open a new okay, so what I'm starting with is I have a comment here. In this comment here, I want to load my picture in the workspace, and for me to be able to load this picture here, I just use the ImRead to read the picture. So we use ImRead in MATLAB to read the pictures. Okay, so I'll uncomment this, and maybe I can call this one test, and I want to read this picture candy. Which picture candy? I put it up here in my folder that I'm working with. I suppose I have it here, candy here. Okay, so I have my picture. Let me run it and save this as image processing demo. I'll save that file and I run to be able to run here. Let me just clear CLC, my command line, so it's able to run, and I'll need to show this image. So the next part is for me to show the image. Show the image. I use ImShow, and then I want to show the test image that I got. Let me terminate this line. When I run that, it will be able to show me my picture here. I have a candy. I have a candy toy picture here. I have some toys, and then some candies. Okay, so able to read the picture very well. So the next part we need to do is for us to be able to use some functions. There are some functions that do image processing, and I want to ask you at this point, let me just get this. At this point here, for you to be able to get this ImTool function, you will need to download it or install image processing toolbox. MATLAB already provides this. If you install MATLAB and you all installed all the packages you should be having this. But if you selected, because MATLAB comes with over 20 GB of different libraries and technologies that you can use for you to be able to do a lot of things, from basic programming to complex systems like space stations and all those other big stuff. Okay, so if you have MATLAB installed, you have to have this. But if you did not install, I'm just going to show you here what you need to do. I said you have to install this, because if you don't have it, it will complain you don't have this IM tool function. So you just need to have my version of MATLAB. I'm using 2021A. So if I launched it, when I launch this, it will necessitate me to install, so you know how to go through the installation process of MATLAB. So we have options here. I have a file installation key, and then select yes. Of course, you can read through the agreement. It's always important. Go through the agreement, and then you go next. So it will ask you to put in the installation key. You just come back to your folder. In my folder here, I have the README file. You'll be able to see this unzipped folder. I have these other files which are very important to use. I have the license.lic. You are going to be able to use this to install. You need this README file to check. So you go through step by step the number of things or steps in here for you to follow. But we've been asked on our window here to put in the installation key. Number 2 provides us with the file installation key. So just copy that installation key and put it in. Next. So it will ask you to enter the license key. So the license key is the file that you have here, the license.lic, this file here. So you just browse to that file and you get it. So you come back here, browse, select the file, okay, and then you go next. You know where you're installing your programs on C. Go next, and so as it loads, I just want to show you here's something that you need to. Okay, you can have All right, so you have this list, and for me to show what I've already installed, the pre-checked, you can see that they range from MATLAB parallel server, you have Simlink, 5G, aerospace blockade, aerospace toolbox. Okay, if you're programming for aerospace, antenna, and many others. So because you are going to be using a little more of these, you select audio, and then you select also computer vision, and then you select also DSP, because these computer vision and audio and image processing, they work basing on this DSP system toolbox. So you need also to select this, and then you come and select image processing toolbox here. Okay, so once you have that, then you just go to next, 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 until you finish. So I don't have to do this because I already installed mine. Okay, so you just need to make sure that you have yours already running, and that is okay. So I'll close this window. For me, I don't want to install them because I already have them, and I go back to here. We want to use the M tool function for us to be able to see the image that we have. So the M tool function, I'm going to pass the test. Meanwhile, as you look at your value that you have loaded your image, you come to workspace, and it will be provided here where you have the variable here test, having the colors of RGB, okay, with the type of that image that is being stored in. So you have 225 times 225 times 3, okay, which is UINT8. Okay, so be able to do that, and then you just need to test. So I'll just test here, and then let me comment this, and then when I run, I'll have image here. The IMF, sorry, not the IMF, the IM tool is a very powerful tool in making edits and determining distances and pixels as you're able to look at the size of your image. So when you look at image, if I run it again, this is my image. I can be able to zoom in. Okay, there's this icon here which measures distance. Once you click on this icon here, and then you want to measure the distance of this toy from here to here, you can see that as I pass, the pixel info is being shown as you move the cursor. You can be able to see the number of pixels there shown. So I can be able to determine the length, okay, and then maybe the width. Okay, so it will help you to measure, and as we go on, you'll be able to know why we'll need this, because understanding the pixels and reading the information here of you. Okay, to enable you to enhance your image, especially if you're going to use the geospatial when you're calculating distance. This can help you to calculate distance from maybe one place to another on an image. Okay, you can also be able to add value. There's this icon here, so you inspect pixels. You can inspect the pixels on that image, and you can see we have this pixel region, which is an image tool, and gives you the RGB combination of the image. So wherever you put the cursor, you can be able to move. Sorry, can be able to move let me run it again. If I wanted to check the distance here, I'll run that. Okay, and then I can inspect the pixels. Okay, as you move, you will see the pixels moving. See, be able to move. As you move away, comes the gray becomes less. As you move closer to a point, you find it becomes a little compacted. Okay? So you can be able to play around with your image in that form using that. Okay, so we have been able to read our image using the image tool we have just installed, and then we're able to get to we want to check the RGB because of us reading this image here. We need, first of all, step one, we want to read an RGB image and then look at the standard, the true image. Okay, so instead of using the IM tool, and by the way, if you want to get a little more on an image, you just right click on it and open help on MI tool. They will give you a little more details. This kind of function opens an image view app, and of course there's a little more information on that. Description here, the function opens the image viewer app, and then of course the app represents an integrated environment for displaying images and performing common image processing tasks. Okay, so you can be able to go through and read about that, and then check out the example, how to read different images, and then a lot of stuff on that. So every time you want to learn about a function, you just need to right click on it and then be able to go for help. It will give you help. So instead of using the IM tool function, we're going to use the multi-banded read function. This is going to help us read an RGB image. Remember, the image that we saved, we want to read is the Paris image. but we're going to get it and then be able to work with it. This is the image that I want to read. So let me just copy this. Okay, so saying that step one, when we're looking at image enhancement, we first of all need to read the image and then be able to work around it and do the processing and see how the image is and be able to start doing simple processing on the image. So the first thing we need to is to read the image using the multi-read. When you seek help on this function, you would see that this function reads a band interleaving data from a binary file. Okay, so it reads an a band interleaved data from a binary file. So that means images are stored as matrices or as a series of an array of ones and zeros, or as a binary file, which is a 2D dimension and can be transformed into a 3D and many others, as looking at image and video processing. So this method here, multi-banded read, will help us to read, and this is the syntax, how to write it. And then there's a lot of description on it on providing a 2D image display. Of course, can be able to function and defines a band as the third dimension, the 3D as shown in this aspect. So we want to have the image in a 3D dimension. This one here, the ImageRead, gives us in a 2D dimension, but the RGB is in 3D dimension. So it's quite a composite image or composite color, or we'll look at vector images. Okay, please go back and read the notes as I mentioned earlier. So when you get this function here, then you need to go through and read where X is a 2D array, okay, but you want to transform it to a 3D. That means having X, Y, and Z X labels, and then you have a lot of other details, and then of course examples how can be used. So please just utilize the help function, will help you get familiar with functions in MATLAB. Okay, so once we have our image here, we're going to call it true color image. We want to true color image and want to load that image. And if I run this part of file, it will run. Sorry, I don't need to run this. Let me just comment this. Let me just comment these parts. So once I run this, it will run, but definitely it will not be giving me details. But if you looked at the workspace here, I have a variable true color, which has a value of 512 times 512 times 3 here, which is this image that I've set here. Okay, so this is the image that you want to run, and these are the parameters that we are passing for us to get the dimensions of this image. Okay, so after having that, then you're going to run. So the true color composite has a very little contrast and is and the colors are unbalanced. We'll see that they're unbalanced. So let me just copy this part here for me to run it. So I'm going to the comments, I'm going to uncomment this because we want to get a figure, and that figure we want to show our image. Our image is the true color. We want to show the image here. So if I run that, it will show me the image, which is actually about purple. Little, you can't understand little what is all about this image. But you remember that our purpose is to transform this image, which we have just seen here, this image here, okay? So I think you can be able to see that it is the same image that I have in, okay? You can see that this image is the same as this. So it has been located like this. So this is the image that we are reading and getting us these details. So when I show that image, it will show me how it is. I can just put on the title, and then maybe I would want it to have some text size being set. The source of that image, I just call it testing image, but I can call this multimedia technologies. Maybe incorporation. Okay. Then I would want the font size image to be 7, and then alignment should be right, the image. So when I run, this will be our image. Our title is unenhanced, true color unenhanced, and this is multimedia technologies incorporation. That means its source. Okay, so we are able to read our image here, and we want this image to be processed. We want the image to be processed. Okay, I'll be able to let me comment that. The next part that we want to do, which I've called as the second step, is for us to use a histogram. We want to use a histogram to explore the unenhanced true color composite by viewing the histogram of the red band. Remember, we have the red band, the green band, and the blue, the RGB. So we have a spectrum of colors, and would want to load that and be able to enhance that image to give us the real feel of the RGB spectrum of colors that an image could be. So as we're enhancing to give us a real clear picture of from the blood, or a noisy picture. So what we're saying that we want to see the data that is concentrated within a small part of the dynamic range. Okay, so I'm going to just copy this, and I will be able to put that here. We're running a figure. Said step 2, we want to use this histogram to explore an enhanced true color composite by viewing the histogram of the red band. So I want to only see the red band, which is one aspect of the true colors. So if I run this part, just using the hist function, as said, for you to learn more about the function, you just go back to, you right click it and go to help, and then be able to get the details on that function. This function histogram is this histogram of image data. So it is going to give us a histogram of the image data that we have here. Okay. So if I run this, yes, it will give us this image here. You'll realize that the data is a little concentrated in a certain region. It is not distributed evenly, you can see. So that's why we find that the image is not giving us really good picture. It's not very clear. It's because the data is concentrated in certain zone. So this can help us see how we can be able to change this to enable this picture to be able to become a little more clear and a little more enhanced. Okay, so after doing that, in step 3, we're going to do is we're going to use the correlation to explore an enhanced true color composite. It is another reason for the dull appearance of the composite is that the visible bands are highly correlated with each other. Remember, the visible bands are correlated with each other. So 2 and 3 bands scatter plots are an excellent way of us gauging and understanding the degree of correlation among the spectral band. You can also make them easily adjustable by using a plot. Okay, so what we want to do is to see if we can be able to literally adjust here using a correlation. We want to explore using a correlation, and we are saying here that that's another reason for us to have a dull appearance of the composite picture, which gives a visible band to be highly correlated with each other. So band 2 and band 3 scatter plots are excellent way that can help us gauge the degree of correlation among the spectral band of these colors in this image. So we can be able to look at the texture. Remember, if you're doing image processing analysis, you can look at texture based, which you can look at later on. You can go research into that, also be able to come up to rank images based on what they represent and something like that. So I'm going to copy this. I had written already this in, so I'm not going to type again. So I'm going to be able to run this. So I'm going to comment this, and that. And I have RGB here. So I have the R taking on this color, G taking on this, and then B taking on that. This should be 3, not 1. Okay, so when I run this, it is going to give us, we are getting the red band is here. Okay, and then we have the second one, which is the green band, and then the blue band. So the red, the green, and the blue. And you can look at the concentration of the color. They're in one place, so which is giving us a poor image in that. So the scatter plot can also tell us that there's a big correlation in this spectrum with the colors uh, of green and blue in relation to the red color. Okay, so can be able to try to modify that. As we go to step 4, just need to understand that the trend of the linear trend of the red, green, blue scatter plots indicates that the visible bands are highly correlated. This helps to explain the monochromatic look of the unenhanced true color composite. It looks as if it's a black and white. It is really not understood. It is really oblique and vague. It's because there's a serious correlation in these colors. So they are indicating the red green scatter plots are indicating that the visible bands are highly correlated. Okay, so the next step is for us to enhance the true color. We want to enhance the true color with the contrast. We want to make a little contrast, okay, of the color, bring in some brightness, and then say that the darker regions can be brightened up, and then see if we can be able to change a few things here and there. And there we use a function called ImageAdjust. I said earlier that you just need to go to right click to it and then just go to ImageAdjust and select that function, and then you'll be able to read about it in the help function or help section of MATLAB. It will help you to understand a little more about what the function does. So adjust image intensity values or color map. Okay, that function will help us to adjust the image intensity. So we want to adjust the concentration to be little distributed so that we can come up with a contrasted image or an enhanced image. That's what we want to look at here. Okay, so I'm going to copy up this part and I'll just paste here. Of course, I already had this. Let me just okay, so at step 4 here, we are going to create another variable here, which I call stretched true color, and we're going to run the true color image that we already set up here, already here, and this image here, we are going to use the stretch line. So we are using the ImageAdjust, which I've told you about, but also want to stretch this image. So we're going to use the stretch limb function. The stretch limb function, it finds the limits. You're trying to put the limit to contrast the stretch of that image. Okay, so it always provides you with the low limit and the high limit to that. So it has It will compute the low and the upper limits that can be used for contrast stretching the gray scale or the RGB image of the image. The limits are returned in a low high. By default, the limits specify the bottom, which is 1%, and the top, also 1% of all values. So look at the example. We're looking at an example here of an image here, and then be able to get to this. So you can see this is a blurred image, not understood well, and then this one tries to be a little clear on what we want to come up with. Okay, just going through that. Okay, so I need to close this. It's always important to terminate. So I have this line here. It's very important because this line is going to give us the true color image. Adjust it using the ImageAdjust function, and this ImageAdjust function is going to, we want to set the limit of the true color object image, and we'll store that in this variable. And then when we show that stretched true color image here, it will be able to give us a contrasted, a true color composite after a contrast. And if I run this part here, you can see now that from our previous, let me just go back a little and let me undo this and this, this. This now to be this. This is what I was showing. You can be able to see the difference. Okay, so we have two pictures here, as you can see. This is our original picture, and this picture we had, it was really so concentrated here, and as we saw in our histogram, and of course the scatter plot show that the concentration is around 50. And now we are having a little better picture that has come up here, and this better picture we're able to see some green, shades of blue, and of course some kind of brown and some shades of white. You can be able to see. So that means that this is a satellite image, so it's able to be able to try to get what the image is literally is and what was the original one here. So you can be able to get a little more information on this and a little more clear on this image than on this image here that we're looking at here. Okay, so okay, okay. If I run again, this is an image that we've come up with. So if I went back to my slide, our aim is for us to be able to transform this to this image here. Okay, and if you looked at this image here, you would see that it's slightly trying to appear like this one, though not yet more clear. But our aim is to make it a little more clear and clear and clear. Okay, so what we want to look at again is this. Okay, this. Okay, so the next step that we want to come to is step 5, where we're going to check the histogram after the contrast stretch. The histogram of the red band, which is the third band in our histogram that we saw, will appear after applying the contrast stretch. It shows that the data is spread over a much more dynamic range. The data will be spread over, and you're saying that we're trying now to see it's being spread over of a dynamic range. And let's try to test that on the red band. Red band is the red color that we're trying to run previously. So I'll just copy this, and here we're going to just put a histogram, okay, of the stretched color. We want to see the histogram for this. Okay, so probably maybe let me comment this. Let me leave this because I'm going to be using this variable here that I'm trying to look at the histogram, that variable. So I'm running a figure for histogram using the IMHist function, and I'm passing the stretched true color with the third band. Okay, so if I run that, it will give me, you can see that we have something better now. If I first took you back a little, you agree with me that we had a histogram right here, a histogram here on this. If I run this histogram here, if I run this histogram and compare, you can now see that in the previous picture, or the picture we have that has purple, this picture here is represented by this histogram, showing that the data is literally concentrated around a narrow band around 50. But after performing an enhancement on the same band, the same band that we're working on, you find that the data is distributed, it's evenly distributed, okay, which makes this a little more clearer than this image here. So our aim is to transform a more opaque, obscure image into a more clear image. That's what we call image processing. I hope you're following very well. If you have questions, please you set them. I'll be answering those as I come to the physical class. Okay, so we're able to get that. So we're already able to get a histogram here that shows that we're really moving. Okay, the red band after a contrast. We have contrasted this image here. Okay, the next part that we need to look at a step is for us to be able to enhance the true color with the composite with the decoloration stretch. We're going to enhance that true color, but want to use the decoloration stretch. So in other words, it is another way of enhancing a true color composite which enhances color separation across a highly correlated channel, okay, or channels. So we use a function decostretch function, this function here, for us to be able to perform the decorrelation. The decorrelation one is decorrelation, okay, stretch that is followed by a linear contrast. Um, a linear contrast of okay, a linear contrast stretch as contrasted by the optional parameters that we pass, the total and the value of 0.01. Okay, so what actually I'm saying is that we can be able to use another way for us to be able to make this image a little more contrasted by using the decorrelation function. This function will enable us to separate the colors across highly correlated channel that we're working with. Okay, so I'll just copy this part here. Of course, you have already done uh, the title and all that. So what we need to understand is using the decorrelation function. And I say that every time you want to understand about the function, right click about it and go to help on that function. Okay, so you find that this function here applies a decorrelation stretch to a multi-channel image. And then you have a lot of descriptions. Then if you have an image that kind, okay, where you're having shades here, and you want to clear them, you can be able to come up with a better image which is enhanced like this one. That's what we're trying to do. Okay, so I'll just paste this and let me just comment and comment this. Okay, so if I run this, passing the true color, and with this option tool with 0.01, if we run, you should be able to notice a little more different. I think you can be able to see that our picture is a little more clear. Okay, so if I took you back, you can see that our aim, we are getting to what we want to get here. So we have now a little more spelled out green, blue, and then you have some red, you have some whites. You know, it is a little coming up, little more clearer and clearer. So this using the correlation stretch will help us come up with a majorly better picture. Okay, and probably for today's lecture, lastly, we want to come to stage 7, where we want to check the correlation following the decorrelation stretch. You can check the correlation when you're following the decorrelation stretch. At this, we want to check the RGB, which is as expected. The scatter plot following the decorrelation stretch will show a strong decrease in correlation. It's always strong decrease in correlation. So the RGB may not be as correlated. So trying to plot this. Let me just copy this. And let me comment this, comment this, comment this. Okay, so if I run this, we'll have a correlation of this kind of a scatter plot where we have the colors being literally evenly distributed. You can see in the spectrum that actually the colors are not in one place. This is a better image, and Staff has come up with a very clear image as we saw up here in our picture. Okay, so okay, so that's to looking at. So today we have been looking at majorly the goal of demonstrating or changing such an image, importing it, visualizing it, and then of course correct by performing a contrast, an enhanced contrast and balanced colors. We've been able to do that through the example we've had. Okay, so we have been able to visualize our image. In summary, we have been able to visualize using histogram and the scatter plots, but also we have been able to perform an enhancement contrast using the contrast and the decorrelation stretch that we have looked at in this class. So in the next class, we're going to look at another aspect of image processing. Okay, if you have questions, please you prepare them and send them to me. I'll be able to answer those. I'm providing this the source code to you on Moodle, so please check your Moodle file. Okay, let's meet in the next class, and I want to end here. If you have questions, have to send them in. But also, you're going to have an exercise to do on this to understand if you have been able to understand how to perform this. You're going to get an image of your choice and try to do an image processing techniques that we have explained, applying them to that image in this lecture. Okay, see you, and bye.